Alright, my throat's feeling a little sore today, so if this isn't so good, I apologize, but I'll just be clearing my throat and I'll edit it out. So, today we're going to be continuing our series on converting polynomials between standard and factored form. Today we're going to start the part on complex numbers. I'm assuming you guys know what those are. You gotta know what imaginary numbers are, and then you gotta know what complex numbers are. Alright, so I got 4 examples today, and they're going to be a little complicated, so just do y'all best to follow along. So I have our standard form and factored form up at the top. I'm going to have that up there for every part of the series, so we know standard form, x to the third plus bx squared plus cx plus d. There's going to be more terms, less terms, but you see how you got those exponents. Whereas factored form, it's going to be in parenthesis. It's going to be x minus p times x minus g times x minus k. Could be more factors, less factors, but it's going to be in those parentheses. Alright, so first problem is x plus 4 is a factor of x to the third plus 4x squared plus 25x plus 100. Factor completely over the complex numbers. So, what we're going to do, we're going to take our x and our 4, we put it in the table, and now we need our x to the third. X to the third divided by x is x squared. You guys have been following along with the series, you know how it is. And we got 4x squared, and I only need 4x squared, so we're going to put a 0 right there. That means this whole column is going to be zeros. So then, I need 25x. I need 24 more x's. So 25x right there. 25x divided by x is 25. 25 times 4 is 100. So, see how those add together? We got x to the third plus 4x squared plus 25x on that diagonal plus 100. So then, up at that top, we got x squared plus 25. That means that x squared plus 25 equals 0, which means that x squared equals negative 25. And then we're going to take the square root of both sides, and we'll see that x squared equals plus minus 5i. So our fully factored form here is we got that original x plus 4, then we got x plus 5i, and x minus 5i. And that is our fully factored form. So, simple one to start, just introducing those imaginary numbers there. We're going to go on to the next example, which is write x minus 6 times x minus 4i times x plus 4i in standard form. Alright guys, so you'll see a new table showed up because I realized I skipped a step in what I wrote down. But I want you guys to see this step. So basically, first we're going to take those imaginary numbers there. So we got x, and we got negative 4i, and then over here we got x, and we got positive 4i. And we're going to put those together real quick. So that's x squared, that's negative 4ix, this is positive 4ix, and this will come out to 16. So we got x squared, and that negative 4ix and that 4ix cancel out, so we just got x squared plus 16. So then we're going to take that, and we're going to put it up top here, because now we're going to use that. So we got x squared up here, and we got 16. And then over here we got that x and that minus 6 right there. So putting this together, we got x to the third, we got negative 6x squared, we got 16x, and we got negative 96. Alright, so our fully factored form here is, because it's not on the diagonals anymore. Isn't that interesting? So we got x to the third minus 6x squared plus 16x minus 96. That is our fully factored form there. So you see we took those imaginary numbers there, and I had to put them together to make them non-imaginary, and then I had to add them together. So that is our fully factored form right there. Alright guys, I had to make some edits here because even your tutor here makes some mistakes. But our third example here is going to be find values for b and c such that x minus 4 plus 7i times x minus 4 minus 7i are factors of x squared plus bx plus c. So we see here we have complex numbers. There's going to be a regular number and an imaginary number in those factors. And you're thinking there's too many letters here, but you see here we have 2 factors, and this is a second degree polynomial, which means we have both factors and we can times them together to get our values for b and c. So we're going to put our x, our negative 4, and our 7i. And then up here we're going to put our x, our negative 4, and our negative 7i. And we're going to do all this cross multiplication. So we got x squared here, we got negative 4x, we got 7ix, then over here we got negative 4x, we got 16, we got negative 28i, then over here we got negative 7ix, we got 28i, and we got 49. So then we can do some elimination here. We'll see, we got that x squared right there. Then we got minus 8x. Then these two ix terms will cancel out, so we got plus 16. Then these two I terms will cancel out, so that just leaves us with 49, so plus 49. And that's gonna be equal to x squared minus 8x plus 65. So now we know that b equals negative 8 and c equals 65. So those are our values for b and c. So you see that wasn't actually too hard. And now we're going to do our final example for this one. It's going to be pretty tricky, but I think we can get it done, guys. You can see we got a lot of tables here, so we're going to go through this. Basically, it says x minus 1 and x plus 1 are factors of x to the fourth minus 8x cubed plus 24x squared plus 8x minus 25. Find the remaining factors and write the polynomial in fully factored form. Alright, so first thing we're going to do, we're going to get x and 1 out of there. So we need our x to the fourth, which means we're going to divide that by x. It's going to be x to the third. And that's just going to be x to the third up here. So then we got x to the third. We need negative 8x to the third, so we need negative 9x to the third. And then that divided by x is going to be negative 9x squared. And that's just going to come down here because it's just 1. So we got negative 9x squared and we need 24x squared, which means we're going to need 33x squared right here. And that divided by x is just 33x, and that bring that down, that's just 33x down here. So we got 33x and we need 8x, which means we got to do negative 25x. And that's going to become negative 25, and that's going to bring it down negative 25 right here. So you can see how they add up. I'm going to add them up for you guys real quick. So we got x to the fourth minus 8x to the third plus 24x squared plus 8x minus 25. So we see it all matched up. So then we get rid of that. We can take our top row. We got x to the third minus 9x squared plus 33x minus 25. So now we have this third degree polynomial, and what we got to do, we used this factor. Now we can use this factor. So we're going to put x and negative 1 down here. Then we do our division again. So we need x to the third. That just becomes x squared. That's going to become negative x squared. So then we got negative x squared, and we need negative 9x squared. So we need negative 8 more x squared. And that's just going to become negative 8x. And that's just going to become 8x. So then we got 8x, and we need 33x. Which means we need 25 more x's. And that's just going to become 25, and that's going to become negative 25. So then down here, I'm going to add them up for you guys. We got x cubed minus 9x squared plus 33x minus 25. That worked out. Alright, so up top we got x squared minus 8x plus 25. And this is a quadratic, so we're going to quadratic formula this, guys. I know you guys hate it, but we're going to do it. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's get it done. Negative b is 8 plus minus the square root of b squared. That's going to be 64 minus 4 times a times c. c is 25, and then that's going to be all over 2a. So that's going to become 8 plus minus square root of 64 minus 100, and that's still going to be all over 2, which means this is going to become 8 plus minus square root of negative 36, and that's still going to be all over 2, and that's going to mean we got 8 plus minus square root of 36 is 6i, and that's going to be all over 2, and that can become 4 plus minus 3i. So we got that factored out, and that's actually our last thing, but I like to double check. So remember to put our x's here, and we're going to be subtracting, so that's going to be negative 4, that's going to be 3i, and then at x we got negative 4, and we got negative 3i. Because remember how the quadratic formula is x equals, so then to make it equal to 0, that's when we got to subtract it, so it becomes negative 4. That's why we got these x's here now. So we can double check. We got x squared, we got negative 4x, we got 3ix coming up here, we got another negative 4x, we got 16, we got negative 12i coming over here, we got negative 3ix, we got 12i, and then we got 9. So then we can add that up. We got x squared minus 8x. Those I terms are going to cancel out, so we just got 16. And then those ix terms and those I terms are going to cancel out, so we just got plus 9. So that's going to become x squared minus 8x plus 25. And that is what we had up here. So that's all good. So our fully factored form of this is, we got those two original terms. So x plus 1 x minus 1. Then we gotta write this one out. So it's gonna be x minus 4 plus 3i, x minus 4 minus 3i. So that is our fully factored form of that. So you see how that last one took a lot more work, especially with this double check here, and the quadratic formula and everything like that. But we made it. This is the fully factored form. We came from this 4th degree polynomial and we got it out to its 4 factors. 4th degree, 4 factors. Keep that in mind. So that is that video. I think I'm going to have 1, maybe 2 more videos in this series, guys. Next video is just going to be 2 really hard examples. So, hope this was helpful. You can contact me at legendaryquestions@gmail.com. I will do my best to respond, and I hope you have a good day.